All right, last type. This is a fraction with radicals. First thing, though, is still do direct substitution. When you plug in 3 to all the x's, you get the square root of 5 minus the square root of 5, which is 0, over 3 minus 3, which is 0. So we know this is a 0 over 0 situation. So we're going to have to do something to make the x minus 3 cancel out, because the same with all these 0 over 0s. If you're approaching 3, to get rid of that over 0, you know an x minus 3 must cancel out. That's when you know you're doing it right. So this x minus 3 right here is going to cancel out. How to do that is this. We're going to rationalize. The square roots are irrational parts of it. So to rationalize a binomial, we have two terms, this and this, you multiply by its conjugate. If you don't remember that, or I haven't shown you that yet, it's if you have a binomial, two terms, like a plus b, its conjugate is a minus b. So when you multiply conjugates, I'm going to multiply this by a minus b. If you FOIL it out, the middle terms will cancel. You will get a squared minus b squared every time. So we're going to use that to get rid of the square roots from the top. So the top is in the form a minus b. So I have to multiply that by a plus b. So I'm going to multiply the top by the square root of x plus 2 plus square root of 5. So that was a minus here. To make its conjugate, you change that term to the opposite, in this case plus. But of course that will change everything unless you do the same thing to the bottom. And if you haven't seen this done before, you might be thinking, well, this looks like a huge mess. It isn't. It's really easy if you approach it good. So the top's going to be easy. It's just conjugates. You'll get a squared minus b squared. So a is the square root of x plus 2. A squared, if you square a radical, it just gets rid of the radical. And then you have this minus here. So minus. And then b squared, the square root of 5 squared is just 5. Now stop here and notice something. Remember, we said an x minus 3 would have to cancel out. Look at the top. It's x minus 3. So this looks like it's working already. The bottom looks like a mess, but remember, if you just put it as x minus 3 quantity times this quantity, well, those are two factors. So you don't have to multiply this out. We like factors. Oh, I missed my radical here. Sorry about that. So you have this times this. You can cross this x minus 3 out with this x minus 3 right now. I'm going to rewrite it though to make sure we're all clear. And now you can cancel out factors. These are still all the same, all equal. You're left with the 1 when you cancel out the whole x minus 3. And the bottom is this. So now we've canceled out the x minus 3. That's good. That means now we're ready to do this limit by direct substitution. You plug in the 3, you get the square root of 5 plus the square root of 5. Those are like terms. They're just like x plus x, which would be 2x. Square root of 5 plus square root of 5 is 2 square root of 5. And you're done. Now, I may have mentioned this before, maybe not, but in calculus, we don't normally rationalize things. It's not a big deal. It's not part of our simplification. So that square root of 5 on the bottom is fine. If you did want to rationalize it, it would be root 5 over 2 times 5, which is 10. But there's no need to, so don't. It's okay if you do, but the only thing that could happen is you could screw up and lose a point. So you can check this on your calculator by changing this to a decimal, graphing this, finding the value at 3.001, and make sure they match. And that's it for section 1.3.